Hey there, 11s. We're now going to do some examples of symmetry properties. I'm going to do a bit of question 1, a bit of question 2. So here we go. Let's do question 1. Let's see. So they've given me sine of an angle, theta, is equal to 0.42. So I want you to draw the unit circle for each one to get your head around the concept for each one. Okay, it's very important to get your head around it first so that you can visualize it, and then you can answer the questions without doing so. But I'm going to do the first one. So the first one, they tell me that you have an angle theta and sine, remember, is the y value. So the y value is 0.42. So on the x-axis, on the y-axis, if the maximum is 1, then 0.42 might be about here, right? Now they tell me the angle theta, it's angle theta, so I'm just going to, whoops, I'm drawing a bit high there. Angle theta gives me a height of 0.42. Get me? Okay, so this is the x value I don't know, but I know the height is 0.42. Right? That's all they've given me so far. So for the first one. Second one, they tell me cos of an angle x. So x is obviously different to theta. So I get another unit circle. And I know the angle x will give me a cos, which is the x length is 0.7. So again, maximum x length is 1 in a unit circle, so 0.7 might be here. Okay? So that means this is the point that I could be working with, and this is the angle x. That's my triangle. True? Okay, and so I'm going to write here cos of x is equal to 0.7. This one is sine of theta is equal to 0.42. All right, and then finally, tan of alpha is 0.38. So I'm going to draw a diagram just to help you visualize. So there we go. Tan of alpha, tan is the gradient. So remember, gradient of 1 looks like this. That's a gradient of 1 because it's 1 by 1. So it's a nice isosceles triangle, 45 degrees, 45 degrees. Okay, so this is a nice gradient of 1. So if I have a gradient of 0.38, I expect it to be something like this. Right, so this is a gradient of 0.38. That's what tan is. So tan has a gradient of 0.38, and that angle there is alpha. Okay, so m equals 0.38. Now, if we were to answer question 1, if we were just to pick 3 different ones, I'm going to do F, C, and maybe I'll do a different one. Let's do B. Okay, then let's say B. You're trying to find cos of pi minus x, right? Now, we're working with the x angle. So you notice it's the x angle. So which one's the x one? It's this one. This is the diagram I'm working with. So they want me to find pi minus x. So when I draw my unit circle, where is pi? Pi is over here. This is where pi is. Minus x means I'm going back by an x angle. So this is my triangle here. All right, this is the point. Now they want me to find cos, which means I'm finding the horizontal length. True? So the horizontal length of this triangle, so I'm going to draw the triangle again. This is x, and I'm trying to find this distance. But I already know, based on this property here that at the start they gave us, the triangle, when this is x, the distance is 0.7. From here to here is 0.7. So that means this has to be 0.7 as well, because it's the same triangle. But the difference is it's negative 0.7. Can you see that? So when you write out your answer, you should be writing something like this. You should say this is the same thing as saying negative cos of x, which is negative 0.7. That's B. Okay, if we do C, C is the sine of 2 pi minus theta. So again, the angle's theta. So which one of these have theta? It was this option over here. So they're talking about sine of 2 pi, so I want 2 pi minus the angle. So again, draw your unit circle. Where is 2 pi? 2 pi is over here. That's where 2 pi is, because you go all the way around, you land at the same spot, right? That's 2 pi, and you're minusing, so you're going back by theta. So this is my triangle. See that? So the angle theta there. Now, all I know in a triangle that looks like this with an angle theta is they told us before when we drew it. Do you remember when we drew it at the very start? All we had was If this was equal to theta, we only knew the height was 0.42. So back to this diagram, we only know the height is 0.42, but the difference is that 0.42 is in the negative region. So that's why, to answer this question, I would say this is the same thing as saying negative sine of theta, which is negative of 0.42 or negative 0.42. Okay, and then finally, if we were to do f is looking for tan of 2 pi minus alpha. Again, alpha is this last option over here. But again, where am I working with? Again, if you draw the unit circle, 2 pi starts off at this point. Minus means I'm going down by alpha. And this is my triangle. So I got this triangle that looks like this. And this is alpha. And I know, again, with the same triangle that was given over here before, the gradient was 0.38. So now I have the same type of gradient, except it's still 0.38, but it's negative because the gradient is a negative gradient, not a positive gradient. This is positive, that's negative. So the answer has to then be negative 0.38. Okay, so have a think about what I'm doing there for example 1. Hopefully it gives you a better understanding of what I'm doing there. Let's have a look at question 2. Okay, so I'm going to take question 2 and we're going to try this one over here as well. I'm going to do question 2 right here. So question 2 looks scary, but it's not. It's the same thing again. They're telling you that cos of an x angle, okay, so we don't know what x is, but we know it's equal to negative cos of pi on 6. Okay, so whatever cos of pi on 6, the negative of that, we don't know what the answer is, okay? I do. I know cos of pi on 6 is root 3 on 2, and so it's negative root 3 on 2. But ignore that for now. We're saying that cos of this angle is equal to the negative cos of pi on 6. Now they tell us the region. They tell us it's from pi on 2 to pi is what x is. All right, so we didn't know what angle x is, but if I were to draw this, they're telling me that it's from pi on 2, which is here 90 degrees, to pi, which is 180 degrees. They're saying that you have to be within this region here. So the angle x could be something like this. This is angle x, and that's your triangle. So this is the triangle that I've got in orange, right? That's the angle x, and all we know is the distance cos from here to here is negative cos of pi on 6. That's all we know. Okay, so the question is, what is x? What is x? And what I need you to understand is pi on 6 is the angle they're telling you. They're telling you that cos of the angle, so that means this is pi on 6 here. So if this is pi on 6, then what's the remainder? Okay, and hopefully you remember that all the way here is pi, and if I subtract by pi on 6, I should be left with the remainder. So I know that pi, x will equal to pi minus pi on 6, which is the same thing as saying, you know, like 6 pi on 6 minus pi on 6. And your fractions will give you 5 pi on 6. So I know that this is 5 pi on 6. Okay, so the angle, distance-wise, you can convert radians to degrees if you want, if it helps you, but essentially the answer is 5 pi on 6. So if you type cos of 5 pi on 6, that should be equal to the negative cos of pi on 6 on your calculator. So watch, I'm going to draw my calc. It's in radian mode. So cos of 5 times pi on 6, that's equivalent to the negative of cos of pi on 6. See? Same answer. Okay? So that's what they wanted you to work out. They wanted to know what is this angle here. But they already told you from here to here was pi on 6. So you needed to figure out this entire length here. That's what you wanted. Okay? So the angle is 5 pi on 6. So that's how you do 2a. And it'll be very similar in question 3 and question 4 as well. So you're looking for, so if I'm doing question 4 as an example, let's say a, they said d is equal to sine of pi plus theta. Okay, so what do we have here? Pi plus theta. So pi is from here to here, plus the angle theta, okay, which gives me all the way there. So they want you to find the y value. So d is equal to the sine of pi plus theta. Does that make sense? So pi, think of it as pi is up to here. To get from here to this point, that's theta, right? Now, they've also given you a diagram here. They're telling you from here to here is theta. And you can already see if that's theta, this point has a y value equivalent to root 3 on 2. So that means if I drew theta from here to here, if this is theta as well, well then I expect that the height, okay, the height has to be the same. Okay, so the height has to also be root 3 on 2. You see what I'm doing there? So if I draw the triangle, so at this point, this triangle, maybe I should use a different color, green. At this point, that height, they're telling me it's root 3 on 2. And the angle is theta. So I'm going to do the same. If I did the exact same, but just another color here, starting from here to here is also theta, then that means the height has to be the same, because this triangle that I'm drawing in purple is the same triangle as this. Okay? And so therefore, whatever's here, I can call it beta if you want, and then the angle here would have to be betas too. It's just the diagram looks tricky. Okay? So I know that D has to be root 3 on 2, but the difference is it's in the negative region. The y value is negative. True? So y value is negative, it's negative root 3 on 2. So D has to equal to negative root 3 on 2. All right? Now I know that there's another method to doing this. You can memorize the chart over here. I'm not all for memorizing. That you could do sine of pi plus theta is equal to negative b negative sine theta, and that might have helped you. For me, it's about understanding a unit circle, which is what I encourage you to do. Okay, so that's how you do question 4. In question 1 and 2, let me know if there's more, but this is your most important exercise. You got to get your head around symmetry properties. Okay.